What's up everyone, it's Stack Lessons here. Welcome back to the channel. Today we're diving into Amazon Macie PII detection and data privacy compliance. Let's get into it. Your security team just found 40,000 customer social security numbers sitting in a public S3 bucket. You need to find them, mask them, and make sure it never happens again. And here's the catch. Macie is everyone's first instinct for problems like this, and it's wrong for at least half of them. In this video, we'll walk through Amazon Macie, the 4 tools that actually redact data sovereignty controls, and Amazon Web Services config, so you know exactly which service to reach for at each step. Here's the single sentence that drives every Macie decision. Macie discovers and reports sensitive data, and it never modifies a single byte. The official documentation backs this up with 3 verbs. Discovers, provides visibility, and enables automated protection. Notice what's missing: no redacts, no masks, no removes. When the requirement is to actually change the data, you need a different service, no matter how perfectly Macie seems to fit the rest of the scenario. So what is Macie actually doing? It's a managed service that scans your S3 buckets using machine learning and pattern matching to find sensitive data. It produces findings, which are essentially reports saying, here's where the social security numbers live, here's the bucket with credit card data, here's an object containing Amazon Web Services credentials. The findings never modify the underlying objects, not a single byte gets touched. And critically, Macie is an S3-only service. It has no visibility into databases at all. It does not look at RDS, DynamoDB, Redshift, Aurora, EFS, or FSX. The findings themselves are detailed, down to cell-level metadata telling you which row and which column held the sensitive value. Keep this contrast in mind when we get to Glue Studio in a moment. The Macie documentation uses 3 verbs: discovers, provides visibility, and enables automated protection. Glue Studio's documentation uses a very different verb: transforms. That single difference is why these 2 services stored in completely separate lanes, even though scenario questions often try to make them sound interchangeable. If you remember one image from this video, make it this one. Macie is a metal detector at the beach. It beeps to tell you exactly where the metal is buried, but it does not dig it up, melt it down, or carry it away. For that, you need a shovel, which is Glue, a smelter, which is DataBrew, or a guard at the exit, which is S3 object Lambda. Macie's job ends when the beep starts. Macie ships with managed data identifiers covering most of what you'd expect. Personal information like social security numbers, passports, and driver's licenses. Financial information like credit cards and bank account numbers. Credentials like Amazon Web Services access keys, SSH and PGP keys, and JWTs. Even protected health information like national provider identifiers. But when Nexer Retail has a proprietary employee ID format like EMP-12345, no managed identifier knows about that. That's where custom data identifiers come in. You define a regex pattern, optionally add keywords that must appear nearby like the word employee, optionally add ignore words to cut false positives, and set a proximity rule and severity. Anytime you have a proprietary identifier format that Macie's built-in identifiers don't cover, a custom data identifier with a regex pattern is the right tool. If Macie just sits there generating findings, nothing useful happens. The thing that makes Macie operational is EventBridge integration. Every time Macie creates a finding, it publishes an event with source os.macie and detail type Macie finding. From EventBridge, you route those events anywhere. Lambda can run remediation code immediately. Step functions can kick off a multi-step approval and quarantine workflow. SSM automation can run a runbook that reapplies S3 block public access. The point is, Macie itself does nothing to the data. EventBridge is the wire that turns a finding into an action. Here's the underlying rule. When the verb is discover, identify, or classify, Macie applies. When the verb flips to mask, redact, remove, or anonymize, you need a service that actually transforms the data. Those verbs belong to Glue Studio, DataBrew, S3 Object Lambda, or Redshift Dynamic Data Masking. The verb comes first. Read it before you look at anything else in the scenario, because it tells you whether you're in discovery territory or transformation territory. So if Macie can't redact, what can? 4 tools, and each has a clear lane. Glue Studio Detect PII is for code-based Spark ETL pipelines, where you want to detect, redact, partial redact, or SCPs hash entities as part of your transformation job. S3 Object Lambda is for when different consumers need different redacted views of the same object at read time, with no derivative copies sitting around. Glue DataBrew is your no-code answer for business users and data analysts who want a visual recipe with substitution, shuffling, encryption, nulling, masking, and hashing. And Redshift Dynamic Data Masking is for query time masking inside the warehouse, where the underlying data stays intact and the mask depends on who's running the query. Each of these tools owns one scenario. If you understand why the lanes exist, code versus no code, write time versus read time versus query time, you won't need to memorize anything. You'll just reason your way to the right answer. Look at the verbs in this Glue documentation: detect, mask, remove. These are the exact verbs that disqualify Macie. Glue Studio's detect PII transform is the antidote to the Macie trap. When the scenario says mask PII inside an ETL pipeline before loading to the target, this is your answer every time. Picture a restaurant kitchen that prepares one base dish but plates it differently for each table. Vegan version here, full fat there, allergen-free at the corner booth, all from the same ingredients with no extra fridges. That's S3 Object Lambda. The bucket stores one canonical object. Marketing's access point returns it with emails masked. Analytics gets the same object with credit cards masked. Auditors get the raw thing. No derivative copies, no synchronization problems, just transform on read. When the scenario says different views for different consumers without storing copies, this is the only correct answer. Here's dynamic data masking in action. We create a policy that hashes the social security number with a salt, then attach it to the employees table for the analyst role at priority 10. Auditors get a separate unmasked policy at priority 20. Higher priority wins, so auditors see the real value while analysts see a salted hash, all from the exact same table and the same query. Notice 2 things. First, the data on disk is never modified, the masking happens at query time. Second, that salt concatenated before hashing is critical, and we'll see why in a moment. These 3 techniques get conflated constantly, so let's pin them down. Hashing is a one-way function, deterministic, same input always gives the same output. That deterministic property means you can still join 2 tables on a hashed customer ID, even though you can't recover the original value. Tokenization is different. It swaps a sensitive value for an unrelated surrogate, and a separate vault holds the mapping. Think of it as a coat check ticket. The ticket itself reveals nothing about the coat. PII DSS compliance often prefers tokenization for that reason. Encryption is the only one of the 3 that's reversible with a key, so it's the right choice when you genuinely need to recover the original value later. And tying back to the redaction tools, DataBrew can apply all 3. Glue Studio defaults to SCPs hashing, and Redshift Dynamic Data Masking lets you pick whichever technique fits the column. Hashing without salt is like everyone in an apartment building using the same locker combination. Crack 1, you've cracked them all. An attacker with a pre-computed table of SH256 hashes for every possible social security number can reverse an unsalted hash in seconds. Salting adds a random value before hashing, so identical inputs produce completely different outputs, and the attacker's pre-computed table becomes useless. If you have a choice between a salted and an unsalted hash, the salted version is always the stronger choice. This is the canonical PII governance pattern on Amazon Web Services, and it shows up constantly in real architectures. Macie scans the data lake and finds the columns containing social security numbers, emails, and credit cards. Those findings flow through EventBridge as Macie finding events. A Lambda function reads the finding, pulls out the column names, and writes Lake Formation column-level grants and denies. From that moment forward, every query through Athena, Redshift Spectrum, or EMR enforces those grants at runtime. Unauthorized principals literally don't see the PII columns. The mental model. Macie is the building inspector who walks through and tags every restricted door. Lake Formation is the security guard at each tagged door checking ID badges. This pattern can dramatically reduce the manual tagging effort required when onboarding new data sources, compared to the older approach of tagging objects in S3 directly. Shifting to data sovereignty. If Nexer Retail expands into Europe and GDPR requires customer data to stay within EU borders, this is the SCP that enforces it at the organization level. The structure is a deny statement with a not action list and a condition on requested region. The condition denies anything where the requested region is not EU-1 or EU Central-1. The not action list carves out exemptions for global services, and we'll talk about why that's not optional in just a second. Applied at the organization's root, no account admin underneath can override this, which is exactly the guarantee you need for regulatory residency. Here's the mistake that has burned countless candidates and real engineers. You copy a region restriction SCP from a blog, forget the not action exemptions for global services, and suddenly every IAM call, every CloudFront update, every Route 53 change gets denied. Your entire organization is locked out of identity management because IAM's endpoint physically resides in US-1, which your SCP just blocked. The fix is the not action list. Always exempt IAM, CloudFront, Route 53 support, and STS. Straight from the Amazon Web Services organization's user guide. These services are global, but their API endpoints physically sit in US-1. If your SCP denies everything outside the EU, you're denying calls to those endpoints too, which means IAM stops working for the entire organization. The not action exemptions aren't a stylistic choice, they're the difference between a working sovereignty policy and a self-inflicted outage. SCPs cover the front door, but there's a side door you also need to bolt. S3 cross-region replication is a sneaky way data can leave the boundary, even when your region SCP is in place. Someone with bucket admin permissions can create a replication rule that quietly copies objects to a bucket in a disallowed region, and your residency promise just broke. CRR requires versioning on both source and destination, but versioning is a mechanical requirement, not a sovereignty control. Bucket policies alone won't help either, because the replication rule is created through the S3 control plane, not by writing to the bucket. The fix is an SCP that denies S3:put replication configuration when the destination region isn't on your approved list. Block the configuration action, not just the data movement. Now to the comparison that confuses more candidates than almost any other. Amazon Web Services Config records the state of your resources over time. What did the bucket configuration look like last Tuesday at 3 p.m.? Was encryption enabled? Were public access blocks on? Config can also evaluate that state against rules, and conformance packs ship pre-built rule bundles for PII, DSS, HIPAA, NIST, and FedRAMP. CloudTrail is different. It records actions. Who called which API from which IP at which timestamp. The practitioner shorthand is the cleanest version if you need to know who did it, CloudTrail. If you need to know what the resource looked like, config. Same governance domain, completely different questions. One more critical distinction. Config is a detective control, not a preventive one. It will tell you the bucket was public from Tuesday to Thursday, and it can even trigger automated remediation through SSM to fix it. But it cannot stop the bucket from going public in the first place. For prevention, you need SCPs or IAM policies that block the action before it happens. Defense in depth means both, SCPs as the ceiling and config as the auditor watching what slipped through. Here's the config remediation loop end to end. A resource changes, and config records a new configuration item. The rule evaluates that item, either a managed rule from Amazon Web Services or a custom rule you write as a Lambda function or as a guard policy, which is just Amazon Web Services policy as code language for expressing checks without spinning up a Lambda. If it fails the check, the resource gets flagged non-compliant and shows up in the dashboard. From there, an SSM automation document runs, maybe re-enabling encryption on the bucket or removing a public access block exception. Once remediation finishes, config reevaluates and ideally marks the resource compliant again. One important caveat: service-linked rules like the ones inside conformance packs don't accept manual remediation configurations. Here's the organizing framework for everything in this video. Mature PII protection on Amazon Web Services is 3 layers working together. The preventive layer is SCPs and IAM, blocking disallowed regions and enforcing encryption at the moment of creation. The detective layer is Macie and Config, scanning S3 for sensitive data and auditing configuration drift over time, then routing findings through EventBridge to trigger automated response. The responsive layer is the 4 redaction tools, Glue Studio, DataBrew, S3 Object Lambda, and Redshift Dynamic Data Masking, which actually transform the data, plus Lake Formation enforcing column-level access at query time. Every service we covered today lives in exactly one of these layers, and that's the lens to carry forward. Here's the one sentence that ties this entire video together. Every tool we covered has exactly one job. Macie finds Glue Studio, DataBrew, S3 Object Lambda, and Redshift DDM transform. Lake Formation enforces, SCPs prevent, config audits. Confuse any 2 of those jobs and you've picked the wrong service. The bullets on screen are your decision rules. Use them as a reference when you reason through a scenario. Now let's put them to the test with 5 questions. Question 1. A data engineer needs to mask social security numbers in customer records stored in S3 before loading them into Redshift, using a code-based Spark ETL job. Which AWS service is the correct choice? A. AWS Glue Studio Detect PII Transform. B. Amazon Macie with custom data identifiers. C. AWS Config with a custom rule. Or D. Amazon Comprehend. Take a moment to think it through. The answer is A. The word mask immediately eliminates Macie, no matter how well it seems to fit. Glue Studio's Detect PII Transform is purpose-built for code-based Spark ETL pipelines and offers 4 actions: detect, redact, partial redact, and SHA-256 hash. That's the correct lane. Question 2. A company needs marketing and analytics teams to read the same S3 objects, but marketing must see emails redacted while analytics must see credit cards redacted. No derivative copies of the data may be stored. Which approach meets these requirements? Run 2 separate glue ETL jobs writing 2 redacted bucket prefixes. B. Configure S3 object Lambda access points with different redaction functions per team. C. Use Macie custom data identifiers to detect and remove the sensitive fields. Or D. Apply Redshift dynamic data masking after loading the data. Think it through. The answer is B. The constraint that pins this down is no derivative copies. Glue ETL writing separate prefixes literally creates derivative copies, so option A is out. Macie never modifies data. Redshift DDM only works inside the warehouse, not on the S3 objects directly. S3 object Lambda is the only feature designed for transform on read with different views per consumer. Question 3. A security team wants to enforce that no resources can be created in AWS regions outside AU West-1 and AU Central-1 across an entire AWS organization. Which approach should they use? An IAM policy attached to every user denying actions outside the approved regions. B. An AWS config rule that flags resources created in disallowed regions. C. A service control policy with a deny on AWS:requested region and not action exemptions for global services. Or D. An S3 bucket policy restricting cross-region replication to approved regions. The answer is C. Only an SCP sets a preventive ceiling across every member account that account admins cannot override. IAM policies can be modified locally per account. Config is detective, it tells you after the fact but doesn't block. And bucket policies only cover S3, not the rest of the resource graph. The not action exemptions for global services like IAM, CloudFront, and Route 53 are required so you don't lock yourself out. Question 4. During an audit, you need to determine what the encryption configuration of a specific S3 bucket was on a particular date 3 months ago. Which service provides this information? A. AWS CloudTrail Lake. B. AWS Config. C. Amazon Macie. Or D. Amazon CloudWatch Logs. Take a moment. The answer is B. AWS Config. The question asks about resource state on a specific date, which is exactly what Config's configuration history is for. CloudTrail would tell you who called the encryption API, but not what the resulting state was at a point in time. Remember the practitioner shorthand? Who did it means CloudTrail, what did it look like means config. Question 5. A data lake governance pattern uses Macie alongside another service so that PII columns discovered in S3 are automatically blocked from unauthorized query engines reading through Athena, Redshift Spectrum, and EMR. Which service enforces the column-level access? A. AWS Glue DataBrew. B. AWS IAM directly on the S3 bucket. C. Amazon Athena Workgroup Settings. Or D. AWS Lake Formation. The answer is D. AWS Lake Formation. Macie is the building inspector tagging restricted doors. Lake Formation is the security guard at each door checking ID badges. Macie discovers Lake Formation enforces column-level grants at query time across Athena, Redshift Spectrum, and EMR. IAM can't do column-level filtering on S3 objects. And DataBrew is a data prep tool, not an access control service. This is the canonical PII governance pattern on AWS. And that's a wrap on Amazon Macie PII detection and data privacy compliance. If this helped you out, smash that like button and subscribe for more. See you in the next one.